stratified sampling is a type of sampling that involves random and non-random selection. So stratified selection. So stratified sampling is very key with proportion. So the thing about stratified sampling is that you want to select a sample of people that is in proportion with the size of your population. Let's figure out what that actually means. Imagine this is a group of year 11 students, okay? And you want a sample of 50 of those students. You want to collect a sample of 50 students. Now, I've split this up into the language that these year 11 students are studying. So 145 is studying Greek, 121 Spanish, etc. And I want a sample of 50 of these. But I want my sample in the same proportion as the groups they're in to the language that they're studying. So, for example, 145 out of 650 of them, because there's 650 in total of them taking Greek, I want my sample to be in exactly the same proportion. So what we actually do is we take the proportion and we multiply it by the sample number. So I'm going to do on my calculator 145 over 650, and I'm going to multiply that by 50, okay, the sample size. And that tells us we should be asking 11 students. Round it to the nearest integer, because we can't ask 0.1 of a student. I would write down 11.15 dash dash dash, which means 11 students. And we do the same for Spanish, this time 121 out of 650 multiplied by 50. German, there's 198 of them out of the 650. Multiplied by 50, and finally French, 186 out of the 650. Multiply that by 50 to get your answer. Okay, so just go through working those out. Oops. So 9 in the next one, 9.307. which is equal to 9. The next one, 198. Oh, I've got to rewrite it. Is going to give us 15.23, which is 15. And finally, 186. Gives us 14.3, which is going to be 14. Now, I have a feeling that isn't quite going to be enough students that can our sample. Our sample is 50, and that sometimes happens because of the rounding. So let's add those together. 11 plus 9 plus 15 plus 14. And that gives us 49 students, okay? We haven't got a sample of 50. You might want to take the highest one to round up to the next number, okay? So you might want to take Spanish to round up to 10. That is a GCSE question that's come up in the past. It might be why has it come up with more, or why has it come up with less? And it's all to do with the rounding, okay? Right, so that's stratified sampling, but we need to be able to kind of put it into a sentence about what it's about and why do we use it. And in what situation would we use it? Okay, so stratified sampling selects a sample that is in the same proportion as the population, okay? The groups are in the same proportion as the population, and you would do this when, as I said, the groups are kind of split. Now, how you then go and select those groups, you tend to use random sampling within that. So once you've figured out, okay, I need 11 who do Greek, you'd number the 145 students and generate 11 random numbers between 1 and 145. Select them, ignore duplicates, and link back to the population. So within stratified sampling, okay, there is random sampling happening, okay? Right, here we go. Have a go at this one then. Feel free to pause the video, give it a go, and then press play again after. So let's see how you got on. There are 3 age groups in a competition. The table shows the number of competitors in each age group. So 120 between 16 to 18, 250 and 19 to 24, and 200 are 25 years plus. He wants to do a survey and stratified sample of exactly 50 competitors according to the age group. Work out the number of competitors in each age group. Okay, so as we said, it's the proportion in each age group multiplied by the sample size. Say for 16 to 18, we should be doing 120 out of the total. So we need to add them together, 450, 570. So 120 over 570 multiplied by your sample size of 50. And then 19 to 24, we're looking at 250 out of the 570 times by 50. And then the 25 plus years, you'd be doing 200 out of the 570 multiplied by 50. Get your answers, and that's the way that you're kind of going to do that question. Okay. Okay, once again, this is an example that has gone 1 over. So you might want to take that 18 down to the 17. So you had 50 competitors. Okay, so it'd be 17 for that because that's the closest to the lower value. Right, here we go. Another one. Give a pause and give it a go. The table gives information about the number of students in the 2 years of a college course. You want a sample of 70 stratified by year and gender. So the first year male, I'm going to label that 1, would be 399 out of the total. Okay, so make sure you add them together to get your total. So 399 plus 252 plus 602 plus 198. Takes it to 1,451 and multiply it by 70 to get your answer. So the female first year would be 602 over 1,451 times by 70, etc. But it only wanted male in the first year, so that's the one you'd be working out. So 399 over 1,451 multiplied by 70. Okay, gives us 19.24. So 19 students. Okay, and we're keeping it in the same proportion as the male first years are of the whole population. Okay, right, final one then. So this is a little bit of a different one. This time they're giving you the number in the sample, and you're then figuring out what the original population size was. I would pause this video, give it a good read, give it a try, and press play when you're ready to see the answer. So 340,475 people live in Brinton. A company carried out the survey. It used a random sample of 1,500 of the 340,475 people. Right, let's think about this then. 870 of this sample were male. Remember, how do we calculate the size of the sample? We do the proportion of the population, we multiply it by the sample size to get the number that we should ask in the sample, okay? So we know that that is equal to 870 people. Now, what's my proportion? We don't know how many people there are who are females, but we do know it's out of 1,000, no, we know it's out of 340,475. Okay, and if I times that by 1,500, which is the sample size we want, we're going to be getting to 870, and that is for the males. So we're just talking about males at the minute. So let's rearrange this. Let's figure out, let's sort out what X is going to be, how many males there are. First, we're going to get rid of the times by 1,500 by dividing both sides by 1,500. Gives us X over 340,475 is equal to 870 divided by 1,500. We now need to remove this by multiplying both sides by 340,475, which will say x equals 870 over 1,500 multiplied by 340,475. Okay, pop that into a calculator. And that gives us 197,475.5. So that's the number of males that there are, remember. That's the number of males. So 190, 1974, 75.5. But we need to subtract that answer. That's the males. We need to subtract that from the total population because it wants the number of females. So females is going to be equal to 340,475. Subtract that 197,475.5 to give us an answer of 340,475. Subtract that answer. 143,000. Okay, so that's your number of females. Just massive congratulations if you got that right, because that was a little bit of a tricky one, but you are sometimes asked to work backwards with that. Okay, and that's stratified sampling. Please make sure you are reviewing your flashcards, okay? And when it comes to flashcards for stratified sampling, this is what you need to be writing down.